Hi there, my name is Marcus Hellberg, and in this video I'm going to show you how you can build web apps in Java using the Vaadin framework. So if you are familiar with Vaadin, it's an Apache 2 licensed open source framework that has around 150,000 active developers worldwide. Around 40% of Fortune 100 companies are using Vaadin internally, and behind Spring MVC we are the #2 Java-based web framework out there. In this video, I'm going to show you a few things. First, we're going to take a look at what it really takes to build a complex modern web application and what we mean by modern web application. After that, we're going to have a very quick run-through of the basics of Vaadin, just so you can kind of follow along. And then we're going to spend the bulk of the video doing hands-on development to build an actual full-stack web application using the Vaadin framework. So let's jump in. First, what do I mean by modern web applications? When I'm talking about modern web applications, I'm talking about apps that should, first of all, be fast. They should be good looking. They should be able to handle big amounts of data, and they should be able to support basically any kind of device or browser and not require the user to have any kind of plugins installed on their device. So using the traditional way of building web applications, there are several things that we need in order to do this. First of all, obviously we need something on the server that can pass this data to the client and back. So we'll need some sort of REST controller. On the client then, we'll need some sort of template that kind of lays out everything in the browser. We'll need some CSS to make it look nice. And then, depending on how complex the application is, we'll need little to a lot of JavaScript to kind of tie all these pieces together. And all of this can get really complex very quickly. So that's why we at Vaadin have taken it to ourselves to fight for simplicity when it comes to web development. The way we do that is by simplifying the model used for building web applications. In Vaadin, everything is a component. So if we want a text field and a button, we instantiate a new text field and a new button. Every component gets laid out by layout. So in the previous example, these two components were inside of a horizontal layout. If we change that to a vertical layout, their order would change. They would be stacked on top of each other instead of next to each other. If we want to add any kind of user interaction to our application, which you probably want to do, that's very easy to do in Vaadin. The way we do that is by listening for user interaction. So any kind of component in the Vaadin framework that a user can interact with will trigger different types of events whenever those interactions happen. In this case, we're going to add a click listener to the button component, and whenever a user clicks the button, we're going to add a new label to the layout with the value in the text field. So if we run this, you can see that I can type in hello. If I click, the hello value gets shown. And if I change the value and keep clicking, the value gets updated. A lot of times, though, when we're working with bigger applications, we're not interested in dealing with the data from fields just individually. Rather, we want to tie that data, bind that data to a object. So in this case, we have a person object, just a plain Java object. This could be an entity, for instance. So in order for us to tie this to our form that we have here, we'll use a binder class of type person. We'll then tell the binder to bind the instance fields with this particular layout. What that's going to do is it's going to look at the names of our text fields, and it's going to look at the fields in the person object and match those by name. We can definitely configure this, but this is a very simple way that you can do data binding with kind of a convention over configuration. Finally, our button here can listen for the click event and try to write the bean if there are no validation errors, and then finally show the value in a notification. So let's try this. Type in a first name and a last name and press save, and we can see that we have the notification there showing person.toString, so that's actually coming from the person object itself. lot of times also in applications we need to deal with lists of a lot of data. In Vaadin, this is something that we can do very easily. So in this case, we're going to build a data grid. The grid gets instantiated by just creating a new instance of the grid object. We're then going to define some columns on it by passing in a function reference to first name, last name, and email, and setting captions to those columns to whatever we want it to be. Finally, we call our service, which we have auto wired in here, and get people. That will just return a list of Java objects, and based on that, Vaadin will be able to generate the columns that we just defined, and the user can scroll through and sort all of this data. A lot of times, though, we have much more data than we can kind of reasonably pull out of the database at once. Most likely, the user is not even going to look at all of that data, and even if they do, they're not going to need all 100,000 rows at the same time. So if we want to do that, we can kind of keep the column definitions the same, but instead of querying the database and setting the items to a collection, what we can do is set a data provider. This takes in two lambdas, one that gets in parameters for sort order, offset, and limit, and those we can pass on to our service to kind of page the data fetching. The other lambda here just returns the total count of objects in our database. So with that data provider in place, we can now give the end user the same exact experience, but from in terms of our application running, we're no longer fetching the entire database. We're only fetching data in small pages as they are needed. Any page fetches will get triggered automatically as the user is scrolling along. Now, another thing that tends to take up a lot of time when we're building web applications is making things look nice. To help developers tackle that in Vaadin, we're shipping with a theme engine called Valo. And Valo allows you to define some parameters that it uses to then build a theme that's cohesive and coherent through kind of the entire library of components that we have. So in this first example, we have a background color that has a lightness value of 100%. If we change nothing but the lightness value to 33%, you can see that the theme engine not only changed the background color to a dark gray, but it also understood that we can't have a black text on a dark gray background. That wouldn't be legible. So it's actually going to calculate sane values for all the parameters that you don't set. So it's going to set the text value to a kind of light gray to give it enough contrast to be read. By defining some further parameters, things like border radius and bevels and shadows, we can really customize the UI to look anywhere from the previous kind of web app interface to this Windows-like interface and anything in between. So the theme engine will really allow you to customize your UI look and feel probably 95% of the way there. The kind of remaining 5% of configuration or customization that you want to do in terms of your company's look and feel, you can then build on top of this theme with just plain CSS or Sass. Okay, so that's pretty much the theory. So to sum that up, everything in Vaadin is a component. These components get laid out by layouts. You add interactions to your components by listening for events. And finally, you do all of this in Java. So let's put this knowledge to use and try to build a full stack web application in around 30 minutes with Vaadin. In this video, I'm going to stick to a very classical example project, the to-do app. And we're going to base this to-do app on Spring Initializer. Spring Initializer, if you're unfamiliar with it, is just a way for us to really quickly bootstrap a Spring project that will include a built-in web server and auto-configure dependencies for a bunch of technologies that we specify. So let's jump into Spring Initializer here. We can keep everything as it is. We're just going to declare the dependencies that we want. We will want web, want Vaadin, want JPA for the entity management, and finally we're going to use an in-memory H2 database. And then finally, press the Generate Project button here, and that's going to download a zip file. I've imported the POM file into my IntelliJ here, and you can see that we have a very bare bones Maven project here. So in our Java folder, we only have the Spring Boot application stub, nothing else, and we have a POM file with the dependencies that we define. So we have JPA and we have web and so on. To the dependencies here, I'm going to add DevTools, which is a Spring Boot development tool library that enables auto reloading of changes to our code, so we can move a little bit faster in our code here. So I'll turn on Maven's auto import. We can close this and actually get started building the application. So what we don't have in this application yet is anything Vaadin specific. We've imported the dependencies, but we don't have any Vaadin code, so we can't run this quite yet. In order to do that, we need to do a couple of things. We're going to first create a new class. We're going to call this ToDoUI. ToDoUI will extend UI from the Vaadin package. In a Vaadin application, the UI class is the entry point into your application, and it basically maps one-to-one with the browser window. In order for this to get picked up by the Spring Boot server and get shown, we're going to annotate this with a Spring UI annotation. Vaadin has a Spring add-on that's included here that will auto-configure a servlet that gets deployed based on this UI. Okay, so that's enough configuration. Let's get started with the actual coding. Now I'm going to break this into a lot of small steps just to kind of keep things easy to follow along. You definitely don't need to kind of split this into so small methods when you're building your own applications. But if we kind of take a look at the to-do application that we had and mentally split that into smaller pieces, what we would kind of end up doing is first set up a layout. Then we're going to add a header. Then we're going to add a form. That's the form where we add new tasks to our to-do list. Then we're going to add a to-do list. That's the actual list of to-dos that we have. And finally, we're going to add a delete button for deleting the completed items. We can then use the ID to go and implement these methods and get started. So for the layout here, we're going to use the most simple layout that we have, a vertical layout. So let's implement the new vertical layout. We're going to save that into a field called, let's call it root. That's the root layout. And then we're going to set the content of our UI. So set the content of the browser window to this root layout. So the browser window can only contain one component. In our case, that's going to be a vertical layout that we can then use to display several components. All right. So for the header, we need to display the text to-dos. So let's go ahead and add that to our root layout. Add component. We can create a new label and give it the text to-dos. Simple enough. Now for the form, it's not quite as simple. So if you remember, in the form we have a text field and a button next to it. So if you recall from the slides a little while back, in order to have components displayed side by side, we need to have them in a horizontal layout. So what we need to do here is we need to put the text field and the button in a horizontal layout and then add that to the root layout so that we get the layout that we're looking for. So let's do that. So we're going to create a new horizontal layout. We're going to call that form layout. Then we're going to create a new text field. We're going to call that task. And we're going to create a new button with the caption add. And we're going to put that into a variable. So what we then need to do is just go ahead and add those to the form layout. Add components, task, and add. And then finally add form layout to our root layout. Okay. For the to-do list, I'm going to do something a little bit different. So instead of just instantiating a component here, I'm going to take advantage of the fact that we're running in a Spring container and actually auto wire in a new class. So we're going to call this to-do layout. And obviously this is not something that exists yet, so we need to create it first. The to-do layout itself will just extend vertical layout. So if you remember the spec that we had, all the to-dos are just listed on top of each other. And this is a common pattern when developing Vaadin applications, is that you extend any of the base classes in the Vaadin library itself, and then you give them some more specific functionality that's relevant to your application. In order for this to get picked up by Spring and eligible for auto wiring, we need to annotate this with a Spring component annotation. If you're coming from a Spring background and wondering why this is an annotated Spring component, not just component, that's just so that it wouldn't conflict with the Vaadin UI component class. So it does the same thing, just to avoid a naming conflict. All right, so let's leave that as it is right now and go back to our UI class. So we have our to-do layout. The only thing we need to do is just add it to our root layout. To-do layout like that. And final thing we need to do is add a button for deleting completed. Like that. All right, so if everything works now, we should be able to go ahead and run this application. Let's go to our browser here. Let's close that out. Let's go to localhost 8080 and wait for this to start. Okay, so you can see that we have kind of all the pieces that we're looking for. We have the heading here, we have the form here, we have the delete button. Obviously, we don't have any tasks right now, so that doesn't work. So let's start off by fixing the layout problems, make everything look nice, and then continue on from there to actually build the functionality. Let's go back into our code here. And the first thing we need to do is here in our root layout, we want to have everything centered, if you remember the spec that we're going against. So we're just going to call set default component alignment to middle center, like that. All right, so that's the first thing. For the label, we'll want to add a style name so that we can make it look bigger. So we can call header.add style name. The Vala theme engine that I mentioned earlier comes built in with a bunch of ready-made style names for common use cases like this. So we can just give it the style name of label h1, and that's going to make it nice and big for us. For the form layout, I want that to be 80% wide, so that it's not it's not the entire width of our UI here. And likewise for the to-do layout, we're going to make that the same width. So to-do layout dot set width 80% like that. Let's go ahead and build that. Since we have those dev tools enabled, that's going to start a rebuild here, and that should get deployed. All right, so we're making progress. It doesn't look exactly the way that we wanted it to. There's something really fishy going on with the form here. So if we go into the DevTools here, and let's expand this a little bit to make it easier to read, and take a look at this actual what gets generated. We can see that we have the horizontal layout here, and then we have two of these divs called vSlot. You can see that those are two equally spaced, but the end result that we're getting is not really what we want. What we want to do is kind of tell the layout that this text field should get all of the space that this button doesn't need. So in terms of CSS, that would be very similar to Flexbox. In Vaadin, what we use is expand ratios. So instead of just adding the components to the layout like this, we can actually use another API called add components and expand for task, and then just add the other component. The add components and expand will instruct the layout to give this task text field all the extra space that's available in the layout. So in our case, anything that the button doesn't need explicitly will be given to the text field. We can also go ahead and fix the add button. So if you remember, it's supposed to be kind of blue. So we'll add a style name. And again, we can use some of the built-in ones and set this to primary button theme. So the primary button theme just kind of highlights it visually, makes it more apparent to the user that this is something that they can click on. Also, we didn't have an actual text add there in our spec. Rather, we had an icon, so we can set an icon here to an icon in the Vaadin icons library. And of course, remove the caption here. Let's go ahead and build this and go back to our browser. And that looks much better. So now we have all the kind of pieces that we need in order to actually start building in the functionality. So the first thing we need to do to actually make this a working application is to create a new class called to-do. And to save us some typing, I've already made a template for the to-do. So to-do is just a JPA entity with a string for the text and a boolean for the done. Nothing fancy about that. The other thing that we're going to do is we're going to create a to-do repository, and that's going to be an interface extending JPA repository of type to-do with a key of long. And if you're unfamiliar with Spring Boot, this is everything that we need to provide in order for Spring Boot to provide us with a fully functional repository with basic CRUD operations that we can then use to query our database. Also, to make it a little bit easier to work with this demo app, I'm going to create a new file here called data.sql in the resources directory that just populates the database with some test data. So let's save that. Let's build our application and see what we have. All right, so obviously nothing changed yet because we haven't taken any kind of advantage of using those new to-dos or repositories that we just created. So let's go back into the to-do layout that we left unimplemented earlier. Here we're going to, first of all, auto-wire in the repository to repository repo. And we're also adding a post-construct method where we can set up this class. So because we're in a Spring container, we can't reliably use the constructor of our class to do the setup because the to-do repository wouldn't have been injected by then. So we're going to make an init method and annotate that with a post-construct annotation, and then we can actually do the initialization in here. So when we init this, what we want to do is kind of go to the database, pull up all the to-dos, and show them. So we're going to create a new method, set to-dos, and we're going to call it with repo.findAll. Let's use the ID again to implement this method. And what we want to do here is, first of all, remove all components. So I want to be able to call this method over and over again And if I've already called it before, I want to make sure that I remove any previous to-dos before I add any new ones. Once we've done that, we can call todos.forAll, or for each, I'm sorry, to-do. And for each to-do then, what we want to do is just call add component with new to-do layout. Let's call this to-do item layout, and pass in the to-do itself. Then what we need to do is go and create this class, and we're not going to implement component here, rather we're going to extend horizontal layout. So here, if you remember, what we want is a checkbox with the to-do text next to it. So again, we're going to extend the horizontal layout to build the layout that we want. What we're going to do here then is create those components. We need a checkbox. We're going to call that done. Sorry, we're going to put that into a field called done. Then we're going to create a new text field. We're going to put that in a field called text. And these names now are exactly the same ones that we're using in our JP entity, so that we can use that data binding trick that I showed you earlier. Before we do that, let's just add these two components to our layout. And then go ahead and build this and make sure that we are still on track. Okay, so what we can see here is that we did get 3 of those layouts, which means that it was able to go to the database, pull up 3 of those to-dos, and create this. What we still haven't done is obviously populated these with the right data from the to-do, and also they look a little bit weird. So let's take care of those things right now. So first of all, the text field, we want to add a style name from the Vala theme again. There's a text field borderless style name there, so that way we can hide the border but still let the user change the text. Also, what I want to do is the same thing that we did for the form earlier. So instead of adding both done and text directly, I'm going to instruct the layout how it should allocate the space between these. So the done component should just get whatever space it needs, and then the text field can expand and take any excess space that's available to it. So we're going to call it add components and expand with text. Finally, just to make things look a little bit nicer, we can set the default alignment to middle left. That way they're vertically centered. Okay, so that should take care of the look and feel part. The other part then is, of course, to actually bind the data. So for that, we're going to create one of those binder classes. New binder. That's going to be of type todo.class. We're going to import the one from Vaadin and save that to a variable called binder. We can then call bind instance fields with this. And what this is going to do is look at the fields in this layout and match those to the fields in the to-do object. Finally, we're going to call binder.setBean with the to-do that was passed in, like that. Let's save that, build it, and see where we are. All right. Yeah, so we can see we have the checkboxes here populated depending on the status, and we have the text here, and it's editable, so that's all nice. Of course, we don't have a way of adding new to-dos yet, so let's go ahead and implement that. To do that, we're going to go back to our UI class here, and to the form part. What we need to do, again, is to add a click listener for hooking up that functionality. So we're going to call add.addClickListener. And on a click event, what we want to do is, first of all, we're going to need to create a new to-do that uses the text from the task field, so task.getValue. And what do we want to do with this to-do? Well, obviously we need to add that to the list of to-do, so we're going to just call to-do layout.add. So we're just going to call add on that, create a method here, and what do we want to do when we're adding a to-do? Well, first of all, we need to call repo.save with the to-do, and then we need to update the UI. And what does the update do? Well, basically it sets the to-dos to all the to-dos that are available, and that's what we did up here. So we can just go ahead and refactor this into a method called update, like that. Now, in order to make this a little bit nicer, what we can do is once we've actually added that to-do, we can call task.clear. So we're going to clear the field so you can immediately start typing something new in there. Then we can also call task.focus, which will put the focus back into that field so it's easier to just continue working. Obviously, it would be nice if it was focused from the beginning, so we can go ahead and do that. The final little UX tweak that I want to do is I want to add a click shortcut for the add button. So this way we can hook up the enter key to actually click the button, so that if you're a very busy person with a lot of to-dos, you don't have to actually move your mouse to add to-dos. So we can just do qcode.enter like that. Save that. Go back to our browser. Okay. Hello world. And that works. We can change something. We can refresh. We can see that we have all our changes. We have the new task here as well. So what really remains here is to implement this delete completed. So the way we're going to do that is we're going to this to-do repository. We're going to add a new method. It's going to be delete by done, taking a boolean of done. And this needs to run in a transaction, so we're going to add a transactional annotation on this. With that in place, the implementation gets super simple. So we're going to go into our button and add a click listener to it. So you can see that we can add the click listener also in line when we're creating the button. And what we want to do here is just call to-do layout delete completed. Then go and implement this and call repo.delete by done true. So delete all the ones that have the done value to true, and then call update. Save that, build, go back into our browser, refresh, press delete completed. All right, so that's it for the code. If you want to go in and look at the code, maybe fork the code and continue on it on your own, you can find my code on GitHub under Vaadin Marcus and Spring Boot to do. Also, if you find any mistakes or anything, go ahead and just file issues there, and I'll try to fix them. All right, so at this point, if you're unfamiliar with Vaadin and just looked or watched me code that, you're probably wondering what the heck just happened. Like, you're writing Java, there's HTML happening in the browser, and what kind of magic is going on here? So in order to illustrate that, let's look at a very simple example. We have a text field, we have a button added to a layout. And for the button here, we add a click listener that just gets the value from the name text field and shows that in a notification. So what happens when a user comes into a Vaadin application is that they're going to download an initial HTML bootstrap page that just downloads that CSS, the theme that you included. It's going to download a JavaScript kind of rendering engine, if you will. So we're not cross-compiling your Java code into JavaScript that's getting run on the browser itself. Rather, we're sending over a JavaScript that just knows how to construct the DOM for each of the components in our library. All of this, if you include the entire set of components, is around 300K. You can optimize this further if needed to speed up the first load. With that in place, we get the components visible and we can start working with this. So I can go ahead and change my name in here, press the button, and what happens under the hood here is that a very small JSON message gets sent over AJAX. Now this is obviously just pseudocode, but what kind of happens is that, first of all, it figures out what changed since last time. Obviously the value of the text field changed, so we need to send that over, and there was a click event on the button, and it just kind of takes that information, puts in a JSON object, and sends it over. Then on the server, the framework takes that information and it translates that to actually running this this listener in the JVM. So our click listener here will get run. This is some code that's running on the server. We can get the value from our text field, since that was passed over from the browser, and we can show notification. Adding that notification, again, will create this little JSON message saying that here are the updates to the UI since last time. There's a new notification component, and it should have the caption of Hi Marcus. So again, we're not generating a whole HTML template that we're sending over. We're not moving to a new page. We're just sending a small diff of the UI, what has changed since the last time that we called. So we're keeping the communication super lightweight, super efficient, and that way we can keep the UI fast and responsive, and also allow you to not have to deal with the communication. There's another really nice side benefit to us actually centralizing all the communication in the application, and that is that while we're using AJAX currently as the default mechanism through which we're communicating, you can very easily switch that over to using a WebSocket. Matter of fact, that's just a single annotation on your UI class. So by adding an @push annotation on your class, that's going to tell Vaadin that, if possible, set up a WebSocket connection with this client when it comes in. If it doesn't support WebSockets, it's going to go through a whole list of different fallback protocols in order to find something that's going to deliver the same kind of user experience to the end user. And that's really handy if you have an application where you're more back-end driven. You have things happening on the server that you're monitoring, or you have data coming in, trading data or financial data, or what kind of data you have, maybe monitoring a factory or something. The only thing to keep in mind when you're updating your Vaadin code from a separate thread is that you need to take care of locking the Vaadin session. Fortunately, there's a easy way of doing that, and that's by calling the access method on the UI class. So you can pass in a runnable to the access method, and that runnable is going to get run with the proper locking and synchronization taken care of. Obviously, one of the things that I mentioned earlier that are important when building modern web apps is the ability to work on different devices. So Vaadin has a very strong support for building responsive layouts that can kind of respond to varying viewport sizes and really give good UX for any kind of device. We actually have 2 different ways that you can accomplish that, or 3 if you also count in CSS media queries. The first one is also CSS based. With the syntax that we have here, you can give it width range for a specific part of your application and then define styles based on that. So it's very much the same idea as for media queries, just that you're able to target specific components also, not just the device width or height for that matter. There's also a possibility for you to add a browser window resize listener to your page. That way you can programmatically change out the actual components that you're showing to the client. So this is something that might be really useful if you have huge changes in the UI, depending on what kind of device you're working with. So say if you're showing a data table for desktop users, but only want to show a little summary chart for mobile users, using this approach would allow you to only send over the UI code needed for that specific device at that time. That way, you're not sending over both implementations and only hiding or showing them based on the device used. Vaadin comes with built-in support for all major browsers, including IE 11. We have an extensive suite of tests that get run every night against all the changes, making sure that all the components continue to work in all the different browsers and operating system combos that we're supporting. So that's one less thing that you need to worry about in your application development. The architecture that we have, where you're writing your code in Java on the server and we're essentially using the browser as a rendering engine, allows us to give you a very strong security kind of foundation for your application. So for instance, say you have a delete button that should only be visible to admin users, but not to anyone else. In Vaadin, if you have a conditional statement that hides that component for non-admin users, if somebody had, say, been able to record the user interaction when an admin used that and actually tried to trigger the same request for themselves, Vaadin would immediately understand that since the button is not being shown right now, it can't accept any kind of interaction. It would just deny that. Also, there are a whole bunch of other security-related good practices that are built into the framework itself that kind of take care of a lot of the things that you should be thinking of when building web apps, but don't necessarily always remember to do. The other big benefit of using Vaadin is that you get to really take all the benefits of running on the JVM and in the Java ecosystem in general. So you're able to use your favorite IDE debugging tools, testing libraries, mocking libraries, profilers, you name it. Anything that you can run with Java will run very well with Vaadin in general. So you have the added benefit of this whole big ecosystem that's been built over the years that you can take advantage in your Vaadin application. Another benefit that the Vaadin architecture gives us is that we've been able to also deliver a super stable API for the product. So Vaadin is currently on version 8 and has been around for 16 years. Vaadin, in fact, predates Ajax, for instance, by several years. But due to our API having this strong level of abstraction between your code being on a fairly high level where you're dealing with things like buttons and grids and horizontal and vertical layouts, we've been able to change how we implement those in the browser over time as technology progresses. So we've been able to keep the browser implementation up to speed with the latest and greatest technologies while still maintaining the same API for the end user, more or less. That means that you can easily expect to be able to maintain a Vaadin application for several years without having to rewrite it the same way that you would most likely have to with many of the client-side technologies out there. Now, obviously, our component set, even though it's super extensive, can't kind of contain a solution for every single problem out there. So we've built in a lot of extensibility into the framework. The easiest way of accomplishing this is by going to our add-on directory. This is a directory where community members from the Vaadin community have created their own add-ons, UI components, or helper libraries, and made them available with an open source license to anyone else. So there's a good chance that you would find what you're looking for in the 700 or so add-ons available on this directory. We also have some commercial add-ons that we offer on top of the open source framework. We, for instance, have a very fully featured charting library that you can use to visualize data in your application. We have a spreadsheet library where you can actually edit and open Excel spreadsheets in your web application. We also recently introduced a new drag and drop UI designer that can help speed up the development of your UI by giving you kind of a WYSIWYG look into the UI as it's getting built. So you can drag in components and you can change their attributes and captions and styles, and you can see how those reflect the end result as you're going along. What's really nice with the designer too is it's not only for laying out components, but it will also show you how the changes you make to your CSS will reflect to the end result. So you can easily tweak around CSS parameters and the Valo theme parameters and get live feedback on how those are going to affect your end result. So if you got interested in getting started with Vaadin, head on over to our website and look at any of the tutorials or other help videos that we have out there. We have, in addition to the Spring Boot starter, there are tons of archetypes for Maven or for popular IDEs that you can use to get a project set up quickly. Vaadin will run on pretty much any servlet container out there, and if you're using Spring or Java EE, you can take full advantage of those through the Spring and Java EE plugins that we have. Finally, just going to leave you with the thought that we're always there to help you. So if you have any questions with Vaadin development, or if you need training or actual professional services around building an app with Vaadin, please reach out to us. We've helped hundreds of companies in the past succeed with their Vaadin projects, and we'd be very happy to help you too. Thank you. And if you have any questions, post them in the comments below or tweet me at Marcus Hellberg. Thank you.